Hey everyone, this is the Math Nexus, and today we are going to start with exercise 3.2. So, again, there's not much of an explanation of what we are going to do. The only thing I'm going to explain right now is the fact that you have to understand how to compare powers. Hey everyone, this is the Math Nexus, and today we are going to start with exercise 3.2. There's not much concept in this exercise. I mean, there is concept, but we have already discussed it in the previous lectures. The thing you need to know very nicely in this one is the fact how to compare powers. So the thing is, okay, we can say that 3 to the power 3, sorry, 3 to the power 2, in fact, is equals to 9. Okay. So if we were to like simplify this, we could even say, or you can factorize this, we could say 3 to the power 2 is equal to 3 to the power 2, because 3 squared is equals to 9 itself. Similarly, if we are given a situation in which we are given 3 to the power x is equals to 27. Right now, if you look at it at the first glance, we are going to say it's hard to configure what the value of x is. Okay, so however, if we simplify this 27, because 3 to the power x itself is in the most simplest form possible. So 3 to the power x is equals to what is 27 equals to? Now, many people may find it hard to find out the factors of 27. So the most easiest way is to find out the LCM. Okay, so find the LCM of 27. 3 nines are 27, 3 threes are 9, and 3 ones are 3. So we get the prime factors of 3 multiplied by 3 multiplied by 3 is equals to 27. So we can say that 27 is essentially equals to 3 cubed. Okay. So right now we're going to write 27 as a in terms of its factors. So 3 to the power 3. Now you can compare the powers easily. So x we can say is equals to 3. And that is what this exercise is wholly based on. Okay, so let me raise this. Okay, so wait a second. Let me just get one thing correct. Okay, so for question number one, again, now just remember the concept of comparing the powers throughout this exercise. So 5 to the power 2x, they've told us, is equals to 5 to the power 7x minus 1. For now, it's straightforward. We do not need to do anything extra or something else. Just simply compare the index values. So both of them are same. So we can say that the powers are same. 2 to the power, sorry, 2x is equals to 7x minus 1. Okay, so now we are just going to simplify this. 2x positive 1 is equals to 7x minus 2x, and we are going to get 1 is equal to what? 7 minus 2? 5x. 1 over 5 is equals to the value of x. So that was part A. Quite simple. For part B, we have 4 to the power 2x plus 1 is equals to 4 to the power 3x minus 2. And again, this the index values are same. Just simplify this. This is a straightforward question. 2x plus 1 should be equal to 3x minus 2. So basically what we do is just ignore the indexes for now, and we only compare the values of the powers. Okay. So 2x plus 1 is equal to 3x minus 2. So that is going to be equals to 1 plus 2 equals 3x minus 2x. Okay. So 3 is equals to x, and that's it. This is our answer. That is for part B. Part C, let me see. 1, 3. Part C is 7 to the power x squared is equals to 7 to the power 6 minus x. So first of all, again, we compare the indexes. They are the same, so we can say their powers are going to equal to be are going to be equal to each other. So 6 minus x. So x squared plus x minus 6 is equals to 0. And again, just this is a quadratic equation. Just to simplify this, to make life easier, you take the LCM. 2 3s are 6 and 3 1s are 3. You have 2 and 3. So x squared plus 3x minus 2x minus 6 is equal to 0. And the reason why I'm doing these parts, just I'm giving an overview of these things. And for example, the middle term breakdown and these type of things is because of the fact that they're basics. And if I go in detail for every single question, that's going to take a lot of time. If you want to know these basics like middle term breakdown, go and watch my previous lectures. I've explained in detail. So please do watch that. But again, I cannot, explain each and everything, each and every concept from the very beginning. Otherwise, you won't understand it. So again, just factorize this x as the common x plus 3 minus 2 as the common x plus 3 is equals to 0. So again, these two of our factors are same, so we can say that our value is so our factorization is actually correct. So x minus 2 multiplied by x plus 3 is equals to 0, and x is equals to 0. And similarly, x is equals to positive 2, and x is equals to negative 3. So these are the two values for x. For part D, we have 3 to the power 2x squared is equals to 3 to the power 9x plus 5. So we are going to say 2x squared is equals to 9x plus 5, and simplify this. 2x squared minus 9x minus 5 is equals to 0. So now again, the factors of the coefficient of x squared multiplied by the constant. So negative 10. So we take out the factors of 10. 5 2s are 10, 2 1s are 2. And we have to make 9 out of this. So 2x squared minus 10x plus x minus 5 is equals to 0. And then this will be 2x as the common, x minus 5 plus 1 as the common, x minus 5 is equals to 0. So we have two factors. 2x plus 1 is equals to 0, and x minus 5 is equals to 0. And again, if you were to simplify this, you would get two values for x, which is x is equals to negative 1 over 2, or x is equals to positive 5. So that's it. This is it for question number 1, part D. In fact, whole of question 1. So just simply going forward, this was quite easy. It's probably because you don't have to change the index value or anything. It was quite straightforward. Question number 2, we have again solve each of the following equations. Part A is 2 to the power n plus 1 is equals to 32. So the thing is, we cannot equate each we cannot equate the powers until and unless the index are same in either side of the equals to sign. So the thing is, now first of all, find out the factors of 32. Okay. So we have got 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, and 2 2s are 4, 2 1s are 2. So we get 2, 2, 3. So we have got 2 to the power n plus 1 is equals to 2 to the power 5. Okay. So again, 2 to the power 5 is equals to 32. So again, now the index values are same. N plus 1 is equals to 5 and n is equals to 5 minus 1, which is 4. So that's it. That was it for part A. For part B, again, 4 to the power 2n is equals to 256. So take out the factors of 256. We get 2 ones are 2, 2 are 4, 2 8 are 16. 2 6 are 12, 2 4 are 8, 2 3 are 6, 2 2 are 4, 2 1s are 2, 2 6 are 12, 2 8 are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. I mean, I'm really sorry about the roughness, but it is what it is. These things are basic LCMs. So 1, 2, 3, 4, 5, 6, 7, 8. So 4 to the power 2n is equals to 4. In fact, 4 to the power. Now I'm going to tell you one more thing. In fact, so it is equals to 2 to the power 8. Okay. Again, the index values are not actually the same. You could have divided by 4. If you have done a mistake like me, that I divided by 2, it's no big deal. You just simply say what's 2 to the power 4 equals to. So we can say if we square the value of 2, we get 8. However, we have 2 to the power 8 in terms of 2. So again, 2 squared is equals to 4 and under root of 4 is equals to 2. So if we just say 4 to the power 2 and is equals to 4 to the power 8 upon 2, we can say that 4 to the power 4 is going to be equals to 256. Okay, so this basic logic. Okay, so I hope that's clear. So 2n is equals to 4 because the index values are the same. So n is equals to 4 divided by 2, which is equals to 2. Okay, that's it. This is it for part B. Okay, so for part C, we have what is 2 to the power n plus 2 is equals to 128. Again, this one is simple. Just take out the factors of 128. So 2, 6 are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, and 2 2s are 4, 2 1s are 2. Now just count out the number of 2's which are coming here 4, 5, 6, 7. So 2 to the power n plus 2 is equals to 2 to the power 7, and n plus 2 is equals to 7. So we are going to say n is equals to 7 minus 2, which is equals to 5. And that's it. This is it for part C. Easy peasy. Okay, so for part D, we have 3 to the power 2n plus 1 is equals to 27. So the thing is, again, basics, no big deal. Just take out the factors of 27 in terms of 3. So we get 3 9s are 27, 3 3s are 9, and 3 1s are 3. Okay, so we get 3 to the power 2n plus 1 is equals to 3 cubed. And then again, the index values are same. 2n plus 1 is equals to 3. And just simplify this, 2n is equals to 3 minus 1, which is 2, and n is equals to 2 divided by 2, which is equals to 1. Moving forward to part E, 2 to the power n minus 1. In fact, let me just get it. So 2 to the power n minus 1 is equals to 1 over 4. Okay. So the thing is, this is a different type of question than what we have seen. So 2 to the power n minus 1 is equals to 1 over, now make it in terms of the index 2, so 1 over 2 squared. Now the thing is, we have learned some of the rules for indices and sets. And one of those rules said that if something is to the power of something in the numerator, for example, 2 to the power x, and it's in the denominator. If you want to bring this to the numerator, you just multiply the denominator's power by -1. So what we get is 2 to the power negative x is also same as 1 over 2 to the power 2 to the power x. Okay, so that's one of the rules for indices. Okay, so the thing is, we can say that 2 to the power n minus 1 is going to be equals to 2 to the power negative 2. Now, if you are not accepting this fact, just put 1 over 2 in the calculator, you get 0.5. Put 2 to the power negative 1 in the calculator, you get 0.5. And hence proved that they are the same. Okay, so moving forward, we get n minus 1 is equals to negative 2, and n is going to be equals to negative 2 plus 1, which is going to be equals to negative 1. So that's it. This is it for part E. Let me just erase it so that I can continue. So, okay. For part F, we have 2 to the power 3n plus 2 is equals to 1 over 128. Now, again, this is exactly the same thing as the previous question, just a little bit more lengthy, I could say. Not even lengthy. It's the same. So just find in terms of the power of 2. So 2 multiplied by 6, 12. 2 4 is 8. 2 3 is 6. 2 2 is 4. 2 1 is 2. 6 12. 2 8 is 16. 2 4 is 8. 2 2 is 4. 2 1 is 2. And again, it's really important that you have a strong mental maths concept, because paper one from 2025 onwards, it has become non-calculator. So it's really important to know what you're doing in mental maths. So do practice mental maths a lot. So again, just made to the powers 4, 5, 6, 7. So 2 to the power 3n plus 2 is equals to 1 over 2 to the power 7. And that is obviously, as we discussed before, is going to be equals to 2 to the power 3n plus 2 is equals to 2 to the power negative 7. Okay, so that means 3n plus 2 is equals to negative 7. As the index values are same, we can say the powers are same for now. Okay, so 3n is equals to negative 7 minus 2, which is equals to negative 9, and n is equals to negative 9 divided by 3, which is equals to negative 3. Okay, that is it for part F. For part E, for part G, we have 5 to the power n plus 1 is equals to 1 over 125. And now, again, the factors of 125, it's 5 cubed. So 5 25s are 125. Yes. So 5 to 25, and 5 ones are 5. So that is 5 cubed. 5 to the power n plus 1 is going to be equals to what? 5 to the power negative 3, because we have brought the denominator value up into the numerator. The n plus 1 is equals to negative 3. N is equals to negative 3 minus 1. And n is equals to negative 4. Simple. And these are really basic questions. No need to, be really fanatic about them. You should know these things. Okay, especially if you're an AdMath student, you should know these things. These are the real basics. Actually, there's much more to AdMath than these things, as you'll discover as we go throughout the chapters. For part H, which is the last part, 5 to the power x squared minus 16 is equals to 1. Now, one is quite interesting because, well, you should know the rules for this one. So we know anything to the power what is equals to 0. So if I would say, 1. So if I would say a to the power 0, I would say it's 1. Anything to the power 0 is going to be equals to 1. That's one of the rules for indices and sets. I'd show you that table in the beginning of exercise 3.1. Do watch that lecture. It's in your book also. for the standard maths book. So do look at that book. Those rules are really important. So anything raised to the power zero is going to be equals to one. May it be five, may it be seven, is going to be equals to one. Okay. So we can say 5 to the power x squared minus 16 is equals to 5 to the power 0, and that is essentially equals to 1. Okay. So x squared minus 16, we are going to say is equals to what? 0. So x squared is equals to positive 16, and x is equals to under root 16. Now the thing is, many students would write the answer, it's going to be equals to positive 4. However, that is not the only answer. That may be correct, but you might get a loss of marks for this one. And that's because whenever you find out an under root, there are two possible values. Either it's a positive 4, or either it's a negative value, okay? Because negative 4 multiplied by negative 4 is going to give you positive 16, and positive 4 multiplied by positive 4 is equals to 16. So we don't know essentially what is going to make up that 16. May it be negative 4, or let it be a positive 4. So that's why we take both values in consideration, except if they have given you a range in the question. They normally give for find the values of x for which x is greater than 0. Then we do not take that negative value in consideration. However, if there is no range given, always write an answer of the under root of two values, positive or negative. Okay, so moving on to question number 3. Okay, so again, what is question number 3? So question number 3, part A, and the same concepts, just a little more mixed up. So 2x is equals to 4 to the power 3. Now the thing is that, can we convert this 2 into 4? Yes, we can, but that would be a long concept. I mean, that would be a lot of things. What we can do is quite easily turn this 4 into 2. Okay. And that's what we are going to do. So, what would be the index value of 2 to get 4? Again, we all know that 2 squared is equals to 4. So, 2 to the power x is going to be equals to, I don't know if you heard that. Sorry for the background noise today. So 2 squared to the power of 3 is going to be equals to 4 cubed. Now simplify this, and we know that when we get a case like this, according to the rules of indices, we are going to multiply. So 2 to the power 6. Do not add these power. These are not 3 plus 2 is equals to 5. These are 3 multiplied by 2. Okay. So again, you need to understand the rules. You need to memorize those rules as well, as they are really important. So x is equals to 6, and that's our answer. Simple. For part B, 3 to the power 2x minus 1 is equals to 27 to the power x. Okay. Again, now turn this 27 into 3 because it's much more simple. So 27 and 3, and well, I do know this, but I'm doing this because of you guys. So 3 9s are 27, 3 3s are 9, and 3 1s are 3. Okay, so 3 cubed. 3 to the power 2x minus 1 is equals to 3 cubed raised to the power x. So really important to know this, that when are you going to multiply and when are you going to add? I know I'm I'm repeating this a lot, but it's really important. Like, these basic mistakes can take up to 10 to 15 marks of your exam. So just really carefully do these things. So again, the index values are going to be the same after this step, is equals to 3 to the power 3x. So we get 2x minus 1, as the index values are same now. 2x minus 1 is equals to 3x. And then we're going to go on and say that 2x minus 3x is equals to positive 1. Negative x is equals to positive 1. And x is equals to, obviously, negative 1. That is our answer for part B. Okay, just give me a second right here. Okay, for part C, 5 to the power 3x minus 7 is equals to 25 to the power 2x. Okay, again, we know what's 25, it's 5 squared. So 5 to the power 3x minus 7 is equals to 5 squared raised to the power 2x. Again, these I'm getting kind of tired of solving these type of questions. They're repetitive and like I mean they're the same type of things repeated again and again. So 5 to the power 3x minus 7 is equals to 5 to the power 4x. So we are going to get 3x minus 7 is equals to 4x, and 3x minus 4x is equals to positive 7, and that is going to be negative x is equals to positive 7, x is equals to negative 7. That's our answer for part C. Okay, for part D, we have 3 to the power x is equals to 9 to the power x plus 5. That is going to be equals to 3 to the power x is equals to 3 to the power 2 raised to the power x plus 5. Okay, so x is equal to, I'm just going to directly solve this 2x plus 10. If x minus 2x is equals to 10, positive 10, and negative x is equals to positive 10, and x is equals to negative 10. And that is it for part D. So for part E, we have 4 to the power 3x plus 4 is equals to 8 to the power 4x plus 12. The thing is that neither can we convert this 4 into 8, and neither can we convert this 8 into 4. So we have to do something else. We have to make these index values the same. And how can we do that? We can do that by simply making a common index, which is 2, because we know 2 squared is equals to 4 and 2 cube is equals to 8. Again, so we have to make it into the most simplest form possible, which will make our life easier. Okay, so it's not about how to configure what value to put into this equation, but to bring everything to its most simplest possible value. So 2 squared is equals to raised to the power 3x plus 4 is equals to 2 cube raised to the power 4x plus 12. Okay, so 2 is 6x plus 4 2 is 8 is equals to 2 for 3 is 12x plus 3 1 is 3 3 2 is 6 36. So again, the index values are now same. So we are going to equate this value 6x plus 8 is equals to 12x plus 36 and sorry, not 3x, 36. So 6x minus, I don't know what's happened here. 6x minus 12x is equals to 36 minus 8. So again, this is 6 minus 12x negative 6x is equals to 36 minus 8 is 28. And just cut this down, x is equals to 28 over 6. You could further simplify this by saying 3 is a 6, 2, 1 is a 2, 2, 4 is a 8, which is going to be equals to 14 over 3. And if you want to write this in another form, you could do 3 divided by 14. Um, what can we write? 3, 5, 3, 4 is a 12 minus 2 and 4 whole 2 over 3. In fact, oh, sorry, my bad, I didn't add a negative sign here. So it's going to be equals to negative 4 whole 2 over 3. And that's our answer for part B. Okay, let me just raise this real quick. So now I'm going to go a little bit quicker than usual because, well, these are repeating the same things. So for part F, again, we have 25 to the power 2x plus 1 is equals to 125 to the power 3x plus 2. Again, 5 squared is equal to 25. So 5 squared raised to the power 2x plus 1 is equals to 5 cubed raised to the power 3x plus 2. Now simplify this up. 5 to the 4x plus 2 is equals to 3 to the 9x plus 3 to the 6. So 4x plus 2 is going to be equals to 9x plus 6, and 4x minus 9x is equals to 6 minus 2. Simplify this up. 5x, negative 5x in fact, is equals to 6 minus 2 is 4. So x is equals to negative 4 over 5 if I am not wrong here. Let me just check this out. Yeah, it's right. So for part G, we have 1 over 4 raised to the power x as a whole is equals to 64. Now, then some part of it for us, some is left. Okay, so just simplify this up really quick. We know that 1 over 2 squared is equals to 4, so that is going to be equal. So x and, take out the factors of 64 to 3 is 6, to 2 the 4, to the 2 6 is 12, to 8 is 16, to 4 is 8, to 2 is 4, and 2 1s are 2. 1, 2, 3, 4, 5, 6. So this is going to be equal to 2 to the power 6. So 2 raised to the power negative 2x is equals to 2 raised to the power 6. And negative 2x is equals to 6. X is equals to 6 over 2 negative. So 2 1s are 2, 2 3 is 6. And x is equals to negative 3. That's it for part G. Uh, for part H, what we have is 4 to the power 5 minus 3x is equals to 1 over 8 to the power x plus 1. Now again, we can't convert 4 into 8 and nor can we convert 8 into 4. So we are going to say that 2 squared raised to the power 5 minus 3x is equals to 1 over 2 cube raised to the power x plus 1. Now simplify this real quick. So in fact, I'll tell you one more thing after this. So 2 to raised to the power 10 minus 6x is going to be equals to 1 over 2 raised to the power 3x plus 3. Now, the thing is, many students make the mistake that when they bring this 2 into the numerator, they just multiply this coefficient of x. I don't know why. They say that negative 3x plus 3. However, it's essential to remember that the negative symbol is going to be multiplied by the whole power. So 3x plus 3 as a whole. So that will give us negative 3x minus 3. So just remember that. Many students make that mistake. They forget it. I don't know why. It's much more easier if you just had this negative sign here. So negative 3x minus 3. 10 minus, in fact, let me simplify this. Negative 6x plus 3x is equals to negative 3 minus 10. Okay, we just recheck negative 6 plus 3 and negative 3 minus 10. Okay, so negative 3x is equals to negative 13, and yeah, I'm right. X is equals to 13 divided by 3. And that's our answer for which part? For part H. Okay. Now we're going to go for part I. Let me just quickly erase this. Think I should change my note taking app or something. Something more nicer. I'll look into it. Okay. So for part I, we have a to the power 4x minus 3 is going to be equals to 1 over 16 raised to the power x plus 1. Now, just real quick, simplify this up in terms of the power 2 because we know both 8 and 16 are the power factors of 2. So you should know by now, by the way, I'm not going to take the factor of 16 because 2 raised to the power 4 is going to be equals to 16. So 2 cube raised to the power 4x minus 3 is equals to 2 to the power, what is 1 over 16 equals to 2 raised to the power negative 4 as we have discussed, multiplied by x plus 1. So right, I'm going to just directly solve this up. 4 3s are 12. Okay, I'm going to make it simple. No, that's the main reason I'm recording these lectures, to make it simpler for you. So 4 3s are 12x, um, minus 3 3s are 9 is equals to 2 raised to the power negative 4x minus 4. Okay, so now just simplify this. 12x minus 9 is equals to negative 4x minus 4. Now simplify this. 12x plus 4x is equals to negative 4 plus 9. 12x plus 4x is going to be equals to 16x is equals to 9 minus 4, which is equals to 5. And x is equals to 5 over 16. And that's our value for part I. Okay. Now going forward to part J, 5 raised to the power x squared plus 3 is equals to 25 raised to the power 2x. 5 raised to the power x squared plus 3. Now this one is simpler. I don't know why. Out of nowhere is equals to 5 raised to the power 2 to the 4x, because this 25 to the power 2x is equals to 5 squared to the power 2x. Okay, so we are going to write 4x. So x squared plus 3 is equals to 4x. Oh, that's why it's, in the later part it's a quadratic equation. So x squared minus 4x plus 3 is equals to 0. I'm going to solve this quadratic equation. What would be the factors of 3? It's 3 and 1. So x squared minus 3x minus x plus 3 is equals to 0. And x as the common, x minus 3 minus 1 as the common, x minus 3 is equals to 0. X minus 1 multiplied by x minus 3 is equals to 0. X is equals to positive 1 and x is equals to positive 3. That's our two values for x for part J. Okay, for part K we have 3x raised to the power x squared minus 4 is equals to 27 to the power x. So now what is 3 to the power something which is equals to 27? You should know by now that 3 raised to the power 3 is going to be equals to 27. So 3x squared minus 4 is equals to 3 to the power 3 multiplied by x. So again, the index values are same. X squared minus 4 is equals to 3x. X squared plus 3x minus 4 is equals to 0. Again, this is a quadratic equation. Take out the factors of 4. The factors of 4 are 2 and 2. In fact, we'll take it as 4 and 1. So x squared plus 4x minus x minus 4 is equals to 0. So x as the common, x plus 4 minus 1 as the common, x plus 4 is equals to 0. X minus 1, x plus 4 is equals to 0. So x is equals to positive 1 and x is equals to negative 4. These are two values for x for part K. I don't know if we can solve it in this space. We'll try it out. 2x squared minus 2. In fact, let me just erase part K as a whole. Okay, I have more working space. Just for this last part, then we'll wrap up this lecture and we'll continue the rest for tomorrow. Okay, so we have 2 raised to the power x 2x squared minus 2 minus 8 to the power x is equals to 0. Now there are two ways to solve this one. Okay, either we could say that 2 raised to the power 2x squared minus we could put this 8x in terms of 2 and that would become 2 to the power 3x is equals to 0, and then we could say this 0 is equals to 2 raised to the power something. Oh, in fact, no, we could not solve it that way. I'm really sorry. I thought this was 1. Yeah, there's only one way we can solve this. My bad. I'm really sorry for that. 2 raised to the power 2x squared minus 2 is going to be equals to positive 8 to the power x. 2x squared minus 8x and x. Okay, so again, 2 raised to the power 2x squared minus 2 is going to be equals to 2 raised to the power 3x. And now, as the index values are same, we're going to repeat the same process. 2x squared minus 2 is equals to 3x. Now, again, make this a quadratic equation. 2x squared minus 3x minus 2 is going to be equals to 0. Now, 2 and 2, 4. Wait a second, just give me 1 minute. I'll be like, charge this up. There we go. Uh, okay, so this is 4. What would be the factors of 4 that would make negative 3? Easy. 2x squared minus 4x plus x minus 2 is equal to 0. Now solve this quadratic equation real quick. 2x as the common, x minus 2 here plus 1 as the common, x minus 2 is equals to 0. 2x plus 1 multiplied by x minus 2 is equals to 0. And we have x is equals to negative 1 divided by 2, or x equals to positive 2. For those of you who are wondering how we got this negative 1 over 2, by the way, you shouldn't think like that if you're an math student, but I'll solve for you. So we say that 2x plus 1 is equals to 0. We get 2x is equals to negative 1, x is equals to negative 1 over 2. And that's how we got this value of x. Negative 1 over 2 and positive 2. This is the actual answer for part what? For part L. Okay. So this is it for today. Thank you for watching. I'll meet you in the next lecture with the rest of the questions. Okay. Thank you.